Hi there, and welcome back to another Papetti Math YouTube video tutorial, where today I am going to be teaching you Algebra 1. And in this video, we're going to be finishing up our lesson on GCF factoring with exercise number 4 that says, factor out the GCF from the polynomial expression below. Express your factorization as a product of the GCF and the remaining terms. So if you're looking at that expression right here, that's a pretty long, crazy expression, but that's okay. We'll get through this together. First thing we want to do is we want to look at just our coefficients. And our coefficients are 72, 81, 36, and 108. So pause this video, think of the GCF of just those coefficients. Okay, now that you've done that, you should have gotten that the GCF is going to be 9. Now, if we divide 9 out of all of these, that's going to give us our GCF of our coefficients and what remains afterwards. But we have more than just the coefficients. We have m's. So if we want to divide all of these by the most number of m's they have in common, well, let's see. This one is 5, 3, 2, and 1m. So they all have at least an m. So I'm going to have my GCF of my m's be just 1m. So far we have 9m. And finally, we have n's as variables also. So let's see, we have 3 n's here, 5 n's, 2 n's, and 4 n's. So the most amount of n's they have in common is the n to the second power. They all have at least these 2 n's. So part of my GCF is going to be n squared. So my final GCF of this entire expression is going to be 9mn squared. And what I'm going to do is I'm going to divide each of these terms by 9mn squared to get what remains inside my parentheses. So 72 divided by 9 will give me 8. M to the 5th divided by m will give me m to the 4th. And n to the 3rd divided by n squared is n. I go on to my next term, and I have positive 81 divided by 9 is positive 9. M to the 3rd divided by m is m squared. And n to the 5th divided by n to the 2nd is n to the 3rd. Onto the third term, I have a negative 36 divided by 9, which is a negative 4. M to the 2nd divided by m, which is just m. And n to the 2nd divided by n to the 2nd cancels out because that's just 1. And finally, I have 108 divided by 9, which is 12. And divided by m cancels out. It's just 1. And n to the 4th divided by n to the 2nd is n to the 2nd. So what remains inside the parentheses after you divide out the GCF is 8m to the 4th, n, plus 9m to the 2nd, n to the 3rd, minus 4m plus 12n squared. And if you factored out, let's say, a 3mn squared, and let's just say you factored out a 3mn squared instead of the 9, what you would have inside your parentheses is an expression that does have yet another GCF. And that's one way you could figure out if you factored out the correct GCF in the first place. Otherwise, if you have a GCF inside the parentheses, then you just factored out a common factor, but not the greatest common factor. So again, always check inside your parentheses to make sure there is no GCF inside those parentheses. So for example, there is no GCF of 8, 9, 4, and 12. Well, there is a GCF of 1, but we don't count that in this case. There's also no GCF of our m's, since not all of these terms have an m. This one is missing an m. And the same goes for the n's as well. This one has, this one has, this one does not have an n, so they don't all have a GCF of an n. So that's how we know that we successfully factored out our GCF. And if this video was helpful, please give it a thumbs up. And you're now ready for lesson number 2. Thank you for watching.